in this session, we'll be realizing a full adder system using schematic entry. So we'll close the previous project and then we'll start up with the same project by clicking on Open Project and then Project 1 and project1.xiac. So this was the module what we have already created in the earlier session. So now we'll again choose a schematic file and we'll name it as full adder. So with this, we get one more schematic canvas as shown. So to construct the system, let me quickly show you the equations governing the system. So this is the sum and the carry as sum of product. So here, since gates are available, we'll be using 3 input XOR, 3 2 input AND. We'll select once and click thrice. There we go. And then 3 input OR gate. So we'll type OR 3. So again the system of equation. So in order to connect the components, we'll be adding a wire. So this is the symbol here. So we'll click on the terminal and drag it little far in the canvas. Similarly, one can right click and add a wire, or one can use the shortcut Control W. So the first 3 lines are like signals of A, B and C. So here we place A terminal and at this terminal and B signal over here and over here. Similarly for C terminal as well. Having connected all the systems or the components, we can save the file. And now we need to place the input and output markers. So we'll go to the input output markers and we'll select manually input marker and we'll place it over here. Similarly for the output marker as well. So let's save the file. And now let's rename the ports. So we'll rename it as A, B and C respectively. And similarly, we'll name this as sum and the other one as carry, CY. So the module is ready. So let's verify the design rule. So we'll go to the design tab and we'll select the schematic and then click on check design rules. Since again this system is very simple, it is already verified. Just to be on safer side, one can click on set as top module button, which we'll be exploring more in the later sessions. So by doing that, actually we get some more features for the same module. So now to test the module, we'll create a test fixture. We'll name it as test FA. And we'll select the appropriate module to be tested. If everything works out fine, the test fixture will be generated with inputs and outputs listed as registers and wires. So let's switch to the simulation mode and we'll select the test bench what we have created to test the unit of full adder. We'll scroll down and set all the possible inputs or appropriate inputs, so to speak. Again, we'll be using initial block with delays. And since we have multiple statements, we need to wrap everything in begin and end statements. So we'll copy these initializations. Just to have readability, we'll add extra enter. And since we have not added the end statement, it's popping an error over here. So we'll add end statement. So with this, let's quickly set all the appropriate inputs. So having done the initialization, let's add an extra delay of 10 nanoseconds and then we'll conclude the display, output display, by adding $finish command. So let's select the test bench and not the unit, and then we'll check the syntax. So with the execution of the module with the test bench, we get the result in iSim program. Over here, we'll press the auto set button, and here we can see all the input excitations for various settings what we have made. So to check quickly, we can segregate all the inputs and outputs in one side. Then we'll select the signals and we'll quickly use the cursor buttons on the keyboard to test. So here it is, one input as 1 and sum is 1, carry 0. Same with this. Now we have two inputs, one we have carry high and sum low. Similarly for various other inputs as well. When all inputs are high, sum and carry both are high. So the module gets verified or tested using this. And one can change the color also to display in reports or to preserve later.